Welcome everyone to this Sustainable Smart Home Special Interest Group. I'm Sylvie Russell, Operation Manager at Cambridge Clean Tech. This is the third event of the series for this year. Yeah, it's going to be an exciting one. So just a little of housekeeping. If you can stay mute, the session will be recorded. Please feel free to introduce yourself in the chat room. I would like to welcome my team colleague Oriane and Cynthia. Both of them will look after you through the session. This financing is facilitated by PJB Associates, and Peter will give you a quick recap of the last events and of course introduce you to this one. For those who are joining us for the first time, Cambridge Clean Tech is a member organization. We're here to connect startups, corporates, academics, investors for a smarter and more sustainable future. How do we do this? We do it via events such as this one. We also have opportunities to have access to finance. We just ran the Clean Tech Venture Week. And we also have our next financing in January. So please do visit our website, and we also have all the details in the chat room. We have also Meet the Buyer opportunities, and we're delivering European and international programs where our members can also join when it's relevant. So do visit our website. But for now, let's talk about integrating electrical vehicles with home energy services. And let's see how we can overcome issues for early adopters. Peter, over to you.
Okay, thanks a lot, Sylvie. Okay, sorry, I've just got a couple of ones to move over on that one. Okay, welcome everybody, and welcome to the third Sustainable Smart Homes event. The whole purpose of this special interest group within Cambridge Clean Tech is to address the 27 million homes, particularly in the UK, and in terms of the need to actually reach the legal zero carbon targets by 2050. So the focus is really on sustainability. We're looking at utilising smart technologies to do this, as well as looking at new innovative solutions for the fabric of the property of homes as well in that respect. So those are the three kind of themes for the Sustainable Smart Homes Special Interest Group run under Cambridge Clean Tech. And also I've established a LinkedIn group, which is also called Sustainable Smart Homes. You can get to it from that link, or simply, if you are a member of LinkedIn, just do a search on Sustainable Smart Homes and it should take you to there. I do invite you all to join the LinkedIn group, because then that can become a discussion point in between these meetings which we actually have. So our first meeting we had way back in September, I think it was looking at the developments around trying to improve homes, particularly taking on board the new delivery mechanism, which is known as past 2035, and link that into the Green Homes Grant, which is currently available from the government and has recently now been extended until April 2022, which is good news for people who want to make home improvements. But what we then moved on to was actually looking at decarbonising the home in our second event, and how can we set about doing that. And currently, in terms of heat being decarbonised, in other words, moving away from fossil fuels, etc., like oil and gas, only about 5% of homes have low carbon heating. And Ofgem are actually moving to better understand, with the help of innovators, innovative companies, to look at how can we move towards electricity flexibility system in that respect. Now at this point I was about to show you a video, but it's failed, so we won't attempt to do it today, but we will send you a link on the chat, and also any follow-up message which we do. It will also appear in the LinkedIn group as well. So I'm sorry to disappoint you, because it would have actually put it into context what is beginning to happen, because we're moving towards new flexibility methods, particularly of using electricity. And it's probably organized into 3 different categories. We've got what is called demand side response, where consumers, that's home users in our context, we're only looking at domestic properties, not commercial properties, as far as this group is concerned, can sign up to special tariffs and schemes with rewards, which they will get if they actually are able to either switch off their electrical appliances, or in fact buying electricity when there is low demand nationally, because it's as important to be able to reduce the load of the national grid as it is to meet the demand which is occurring there. And then we're on to kind of battery storage or energy storage of various types. But the main focus today is going to be on battery storage, but we're also moving to looking at heat energy storage, and later events will actually be focusing on that coming up next year. And then we've also got the area of distributed generation, which we are all going to touch upon by our 4 speakers today. And we're still very much in terms of the innovation curve. I'm saying, and hopefully our speakers will either agree or disagree with me, we're still very much at that, we're still very much at that stage of innovators. We're probably only just touching the early adopter stage of these new flexible electricity systems. But today we're going to actually look at ways in which that can be done. I was hoping that having installed for nearly 12 months now in my own home battery storage system, which is a 15 kilowatt system, I was hoping by now I wouldn't have to manually put information in utilising Octopus Agile's flexible tariff rates. Unfortunately, we're still not there yet. I'm told there may be some solutions emerging in January this coming year, and we will hear about one of those solutions with one of our speakers a bit later. For those who attended the last webinar, I actually said I wanted to get an electric vehicle, and I wanted to have that electric vehicle utilising what's known as V2G, or vehicle to grid charging. Well, I have, since that last webinar, now got myself an electric car, and I actually have a battery, a EV charger there, and you will hear more about that because I'll declare an interest. I'm part of the PowerShaper project, which Ben later will be talking about that event. But as far as I'm concerned, I'm seeing that as far as the industry is concerned, you know, there are things which we've still got challenges for industry. Yes, we actually have flexible tariff rates available for electricity. We keep talking about Octopus Energy because it is very much the pioneer in this respect. And but I hopefully will have we'll have 3 by soon, because I understand that Green Energy, I think it is, have actually bought the platform that Octopus Energy use, so they will be hopefully soon offering some form of flexible electricity tariff. And I'm hearing also that E.ON may be moving in that direction as well. So there's some progress as far as offering consumers these flexible tariff rates. As far as the industry is being concerned, flexible tariffs have been around for quite a few years, and demand response has also been around for quite a few years. So in fact, companies in big industry who use a lot of electricity actually are paid to switch off their machines when demand is high for the grid in that respect. But I think it's important what we actually, we're gradually moving into the domestic sector, and where we're getting these various innovations are beginning to emerge. As I said, I had hoped that by December this time, in fact, we delayed this event because I was hoping we would actually get one of the companies to talk about their new vehicle-to-grid charger. Although there are still trials going on about this, as far as I'm aware, there's no publicly available vehicle-to-grid charger which you can buy as a member of the public and put into your, and arrange for it to be connected into your own home. And equally so, cars are very limited in their capabilities to be able to do that. The Nissan Leaf, which is one I just bought recently, mainly for that purpose, that it does have the ability to be able to buy electricity in when it's cheap, but then sell it back again when it's expensive. And because it's got, in my case, it's got a 62 kilowatt battery system, that is certainly going to complement my 15 kilowatt battery system. So there is a kind of an interesting kind of debate as to whether, in fact, the way forward in terms of battery storage in the home, as to whether it's going to mainly focus upon home battery storage systems, or whether, in fact, it's going to be a combination of using an electric vehicle for transport, obviously, and when it's not being used, it can actually be used to store electricity and use in the home as well. Particularly as something like 95% of vehicles are sitting there and not being used. So that's an interesting kind of opportunity there to maybe kill two birds with one stone, possibly, by having an EV for transport, carbon zero, and equally so having an EV charger to store cheap electricity in the home as well. In terms of flexible carbon heating solutions, which are easy to control and install, well, I think we're still at the stage of yes and no in that respect. Again, in future events, we're going to actually explore the opportunities and the obstacles which were occurring in that respect. I think we're not really at this stage of flexible, modular, interoperable solutions. That's still a way off. We've potentially got vendor lock-in in terms of if you've got one type of battery storage system, you can only use one method of controlling it, which is linked to that battery storage system. We've also, again, we're at a situation as far as flexible, easy to control storage, despite the fact there are smart devices around. I'll be honest, some of the heating systems are not as easy to use with at this moment in time. So we're still a yes and no situation in that respect. So before I move on to our first speaker, we slightly changed the format for those who come regularly. We're going to have the speaker. We're going to give an opportunity for speakers, for participants to be able to maybe ask questions, a couple of questions between each speaker to kind of break up the conversation that of the speakers to a certain extent. We're also asking you to take part in a poll, and Orion is going to, I think probably better to put it in again, if you can do, into the chat, so it appears right at the bottom of the chat right now. And if I can ask you while we are speaking to go to that, you'll have to leave, you have to open that link up, give your answers, and then come back and watch it. I mean, you should be able to do the two in parallel while we're speaking at that time. And at the end of the event, we will also have another poll again to see what people's views are, and then we'll compare the two. So I'm going to now move on to our first speaker of the day, who is Simon, or two speakers, Simon Hughes and James Harrow from Green Energy Options, or GEO as they tend to be known, and they're going to talk about the Core for Grid project. This is really a follow-up to what they were talking about last time at the decarbonisation event. So I'm going to pass it over. I'm going to hopefully stop sharing the screen and pass it over to Okay.
Thank you very much. It's Simon Hughes here from Geo, and James Harrow, my colleague, and I will just really pick up directly on a number of the points you just made. Very relevant, I think, to be talking about this increasingly important topic of energy in our lives. Geo is a Cambridge Cleantech member, so we're pleased to be contributing to this series, and an energy technology business just based to the west of Cambridge. So very much focused on this challenge of how you manage the increasing demands on our energy system. I mean, in fact, 42% of those 27 million homes, Peter, you mentioned, now have a smart meter. So we are seeing this digitization, if you like, of this old analog industry of energy picking up pace. And we've been focusing on how you manage energy and control these the increasing number of demands for the last 13 or so years. There are about 80 of us, just as I said, based west of Cambridge, working on this. And what's interesting is we're seeing this increasing pace to the area of the topic of net zero. In fact, there's a BBC article today, some of you might have read, which made the point that EVs are cheaper than petrol cars and more efficient because they're 3 times more efficient, and will therefore accelerate the contribution to getting towards net zero. The other fact that's caught our attention is that over 10% of new car registrations in September, accepting that perhaps those new car registrations are down a bit because of the lockdown, but 10% of those new car registrations were EVs in September. And I don't think any of us would have predicted such a high percentage even a year ago at this point. And what that means is that our homes are going to become, if you like, filling stations, not so much filling stations, but charging stations. In fact, our vision, which I'll show you on the next slide, very much looks at the journey that we hope our homes can take to, or households can take in managing our energy consumption and creating that sort of sustainable future that net zero promises us, but without having to change lots of controls, change the settings, to do that automatically. And the EVs that we'll have, as you see on the image there, will probably double our home energy consumption. And doing so means that charging EVs, as Peter, you were showing, efficiently, cost effectively, and with a minimum carbon footprint, so as not to overload the grid, is going to become an increasing challenge and an opportunity. So I'd like to hand over to James to talk to you about some of the work we're doing in this area. Over to you, James.
Thank you, Simon. And again, thank you to the Cambridge Cleantech team to invite us to speak on this. And hopefully we will touch on some of the topics that we talked on last a month or so ago. But just to give a sort of an update really on what Geo is doing really in the entire capabilities that we have. So we are known, as Simon mentioned, a lot for having the in-home displays, but we also do a lot of other things behind the scenes. So we have an app, we have our home energy management system, or as it's called in a future standard called a SEM. We have a smart heating control. We have smart EV charger, energy storage, solar optimization. We've talked about the IHT, but also about the interfaces towards DSR. Just briefly, we did talk a little bit about this last time on the discussion we had about our Core for Grid trial. This is a technology showcase that we've done, which is based around houses up in Sunderland, in Cambridgeshire, London, and around Sussex, and they have a mix of solar PV. Some of those houses only had a battery installed, so we can compare the difference between houses which had battery and solar. Some had EVs and some had electric heating. We were looking primarily about how do we optimize those devices or those smart appliances between in what we call routine mode in the DSR landscape. And how do we do that when they're just operating without any grid side demand response actions, and then also understand how users engage with that. So in the top right hand corner, you can see the app that we've developed, which actually shows when a DSR service is active. And it's important for end users to be able to not feel alarmed when they see lots of power coming into their property. If they look on their smart meter, it's important that they understand why that's happening and that it's nothing to worry about. And the key output so far, we've seen that a 55% cost savings for the homeowners, and an improvement of 23% in the carbon reduction by doing so. Previously, I talked a little bit about a new standard that the government is pushing, and I'll just to mention it again here for people that weren't on last month's call. There's something that government is pushing through BASE and into using BSI. They've written a publicly addressable standard, and it's number 1878, and that's all about energy smart appliances. Geo is part of the steering group, and I've personally been lots of committee meeting calls on how that standard is being pulled together. But it talks about an energy smart appliances. So these would be maybe your washing machine, but it's typically heavy loads like a heat pump, EV charger, battery storage, etc. And all the property, all the appliances in your home would connect through a customer energy management system, and that would then connect up to a DSR service provider. And the key aims of this is to allow interoperability. So you could switch between different DSR service providers, which in reality may be hidden behind the scenes, but your energy retailer. But also you can interoperable, change your SEM, your customer energy management solution. Here we've shown the SEM is physically in the home, but in practice it could be in the cloud as well. The other thing to mention is that the smart metering is part of this, and on the left-hand side, I'm showing two key things about demand-side response. It sort of happens in two ways. One is the intrinsic, so by using time of use tariffs and also understanding about CO2 indexing, how much CO2 is burnt to generate that energy, we can optimize the amount of CO2, but also the cost for the end users. But when the grid is under stress, so as Peter mentioned earlier, actually there was too much solar in the in the summer months in May, and actually there was not enough demand because we were all in lockdown. So under those constraints, the grid, the DSR service provider, could send a message to lots of SEMs, lots of properties, and actually say, could you turn on your battery storage and actually start charging, or can you start the EV charging, etc. So with that background, I'll move on to talk about some sort of exciting happenings in the EV charging space. So with our old industrial, ICE engines or combustion engines, we're all used to thinking about RPMs and miles per gallons, and having a rough idea of how much fuel we've got left in the tank. With EVs, as an EV owner, you get a completely different dashboard when you're presented. So you can see here, you're seeing the miles, you're seeing temperature. That's actually really important for batteries when you're driving your car. And on the right-hand side, it's all about kilowatts, watt hours per mile, and kilowatt hours. And you can sort of see on here, kilowatts around the edge on that graph, and then you've got the watt hours per mile. So that's a little bit like miles per gallon, and you can even see the regen in the dotted yellow line on the bottom side of there. So because it was really cold when I took this photo, the vehicle said actually you can do very little regen. And actually when you're driving on a cold day, when you normally take your foot off the accelerator and it nicely slows down quickly, you suddenly have to put your foot hard on the brake. So that you have to be aware when you're driving. There's some subtleties that temperature has an effect on. But the key message here is it's actually quite complicated. Kilowatts, kilowatt hours, watt hours per mile. I don't think many, certainly before I had an EV, I didn't appreciate the subtle difference between a kilowatt and a kilowatt hour. Kilowatts is power, kilowatt hours is energy, the stored energy. and the little h on the end is really important. But most people sort of glaze over and start asking questions, and maybe people will understand that. But I think even if you look back on your bill, your electricity bill, they used to call them units of energy. I think now they're starting to talk more about kilowatt hours, but I remember certainly it was just a unit and you paid so much per unit. It's obviously in kilowatt hours. So Geos does a lot of work, and I work with our user experience teams, spending hours on calls and just in meetings discussing how do we make these products really simple for mass market adoption. So simple, easy to use and intuitive, and hopefully delightful to use as well. We have the nice thing about the in-home display is you have at a glance. So you don't, when you get a phone out, I always find that I'm going to my phone for one reason, and then I get distracted by emails and notifications, and you sort of like going upstairs and forgetting why you went upstairs and then have to go back up again. I always have that same problem with apps. The nice thing about the display is it's doing one job really well. It's showing you something that you need to know. So it's this at a glance checking. And when you're charging your EV, it's really important to make sure that you've plugged the cable in firmly. Otherwise you might find in the morning it hasn't charged. And the other thing is about having an effortless touchscreen control, so you can click on the screen and see things and navigate through that very simply. So one of the things that Geo has done is, I mentioned before, we had smart heating. So we've taken our in-home display and we've taken our cozy smart thermostat product, which has been pretty popular in the Nordics markets, but also in the UK. And there's a hub in that second picture. We can see the round hub, and we have RF controlled switches and thermostats, and we have the home app. So what we've done is we've done some convergence. We've taken the hub and we've integrated it into the display. And this is a product we're now rolling out with energy retailers, and it's called Trio Plus Heating. So it's there today. It's something that is primarily used in the UK for controlling your gas boiler. But again, that's important in terms of optimizing and reducing CO2 in that environment. But it's also got the capability of doing other things as well. So what's next for EV charging? And I think if we look back a few years, it was all about the 13 amp plug. You plug that into your vehicle, into your main socket, and then you plug the adapter into your car. People have realized that with going to economy 7 tariffs, you can get a very simple time switch and actually save yourself some money by knowing when it's cheap energy, you can charge your car. And that's improved over time, and you now buy sort of a high-powered home charger unit. And because of OLEV have now said, in order to get the OLEV grant, you have to have a smart charger. And they haven't really defined what that means, but it basically has to be connected to an app so you can do things. The question is what's happening next. Now, Simon's already mentioned, we're seeing, your home energy consumption will double when you get an EV. Your home will become your fuel filling station. Users will want to understand their costs. And if you think about when you fill up with petrol and diesel, you fill up, you maybe put 50, 60 pounds in the tank, and you see the bill as soon as you fill up once or twice a week or every other week. But with electricity, you might only get your bill monthly or even quarterly, and you're going to get a bit of a shock. So there needs to be some way of making sure that users don't get that shock. And it's really important for energy retailers that they don't get lots of customer calls to say, why is my bill so high? If they know in advance what their bill is likely to be because they're seeing that, that's really important. We're also expecting multiple EVs per household to happen. A lot of people have 2 cars at the moment. In a few years' time, there won't be any, it'll be more people have to plug in 2 cars at the same time. So we need to make sure that when you're charging your 2 cars, you're not going to blow the fuse on the property. And also about whole home energy management and DSR. So if you've got solar, can you charge your vehicle from solar? If you've got electric heating, do you put the solar into the electric heating? How do you manage the overall integration with your EV charger as well? So one thing that we found with our call for grid trial, for example, that if you've got a domestic battery and you've got an EV, if you plug the EV in at a certain time when the battery is designed to power the home, it will just recognize the EV as another home load and will start discharging to power the EV, which is actually inefficient because you have a round trip loss through a battery charging discharging cycle of about 80% round trip efficiency. So you're losing 20% of that electricity in heat, not necessarily wanted in your battery inverter. So Geo's really proud to and pleased to announce that we are announced a partnership with EO Charging. It's a company based in the UK, and we're jointly developing what we call our Trio Plus EV. So the Trio Plus is the IHD, which has got the integrated radio control and hub logic built into it. That can provide the heating, the hot water, the solar integration, and battery storage. But today we're going to talk primarily about the EV integration. So because the IHD is connected to the smart meter, it knows the tariff, it knows the usage that you're using. So we get a lot of information from the smart meter directly. Because we know what your costs are going to be, we can actually automatically decide when's best to charge your vehicle, and also optimize the CO2 if we can as well. Because again, that's
sorry, one minute, James.
Peter, yeah.
Yes, sorry, I said one minute. Sorry, we seem to be going a bit. Can you hear me, James?
Yes, I can.
Okay, I just said 1 minute. Yeah.
Oh, sorry. All right. Yeah, the EV charging has the at-a-glance display, and the important thing is it's ready for DSR. The important thing we've got to show is that the government is going to be consulting on this PAS 1878 and whether or not they will mandate that all domestic EV chargers must support this PAS 1878 going forwards. We have a 2-minute video, Peter. I don't know if we've got time to do that, or I can skip over that.
Yes, go on, go for it.
Okay. So this is just an introduction of the Trio Plus EV in action. So we have a car pulling in, plugging in, and I'm sure you've all seen EVs charging before. But actually, at the moment, the car isn't charging because it knows that it's not the best time to charge. You can see that on the display there, it's recognized that the car is connected. So we get that at a glance status. We can also look at the tariff, and the system can know automatically when's the cheapest time to charge. And we still have the app. You can set the preferences through the app. And because it's now midnight, the cheap rate energy, it starts charging overnight as expected. And the user gets to see how far through the charge it's got through. So the user had asked for 50 miles for that day, and they've got their 50-mile charging. So with solar, because one of the things we can do with a smart meter is we can actually see there's some exports happening on the grid. And because of that, during the day, we can actually take advantage of the solar export and charge the vehicle. And here we can see that someone's actually said, I want to boost my charge. So they're going to interact with the display and change what they want directly on the display without needing to go to the app. And then they'll go out and get their full charge that they're expecting. Okay. So really just to sum up on the last slide, we at Geo believe that simplicity is really important for a mass market. So we're working really hard on trying to design that great EV charging user experience so that we can save you money and reduce carbon footprint whilst you don't have to think about it. Thank you very much.
Thanks a lot, James, and Simon as well. Can I just ask people, if you wish to ask a question, do put the question in the chat, but before you put that question in the chat, if you write in capitals the word question, it makes it much easier for me to see which are questions and which are in many respects comments. And you know, some quite interesting comments are actually appearing on the chat. So if I just actually ask one question to Simon and James, you mentioned that you've done a deal with EO Chargers. That's actually an EV charger company. Are you actually locked in with them, or is it going to be possible to use the Trio Plus system with maybe other chargers in the near future?
So right now we are partnering with EO to bring this to market via energy retailers, because there's a bit of process to get the smart meter deployed as part of that. So we can do other integrations with other chargers as well, but we are primarily looking at EO for the start. But definitely that's the question we get asked quite a lot. Can we do it with other chargers? So it depends on the integration. There's some integration work to do, but it needs to be done.
And that's going to be very much the EV charging companies or the manufacturers to actually work with you to offer a solution to their retailers and then their customers in that respect. Thanks again, James and Simon. I'm going to
we have one question from Marco, if you want to take it now.
I can't actually see it.
I can read it out for you. James, so Marco's asked, can the EV driver be sure that the car will be at full charge the next morning, even if overnight prices were high?
So yeah, the intention is that the user will specify the added range that they want for the next morning. And that might be, please fill it up overnight. But it depends on the type of vehicle you have. If you've got a small battery, like you might have a plug-in hybrid, then you might only need 16 hours, that sort of order. If you've got a big 70 kilowatt hour battery and you're only driving 30 miles a day, which is probably about 10 to 15 kilowatt hours, you may only need to do sort of top up, not even top up to full, but top up to say 80% charges. So what we're doing is we're letting the user specify how much they want by when, and then the optimizer will work out the lowest cost way of doing that. So as long as you plug the cable in to the vehicle as soon as you get home, it will take care of the rest and choose the lowest cost time to do that. So if the prices are high overnight, it will try and find the lowest cost price overnight. But we typically imagine that you'd have a 2-tier tariff, which most energy retailers would have. So the intention is you want your car charged, you're prepared to have that car charged at whatever price, but we'll try and do it for the lowest cost.
Thanks a lot, James. I can see from the chat that we've got a question from Rog, but actually I will leave that to maybe later when we have a panel discussion, or there's an opportunity maybe in one of the breakout rooms. If we could move on to Ben from Carbon Co-op, who is going to talk about the PowerShaper project. And as I previously said, I'm declaring an interest because I'm already participating within that project. Over to you, Ben.
Hi, can you hear me okay?
Yes, okay.
Great. Let me just get the screen share going. Tab. Can you see that?
Yes, that's fine, Ben.
Brilliant. Thanks. Yeah, so thanks to Cambridge Cleantech, Peter, for the invitation to join this webinar. I'm hailing today not from Cambridge, but from Manchester. So Carbon Co-op is a energy services cooperative based here in Greater Manchester. I'll talk about that a bit more in a minute. My name is Ben Aylott. I'm a energy systems engineer and the project manager for the PowerShaper project service, and I also oversee our work here in general in the area of energy systems, and have also been participating in the previously mentioned BSI PAS 1878 steering group standard process business, and it's something I think you've also discussed in previous meetings, so I won't talk about that any further. Carbon Co-op here in Manchester, we're a bit of a weird organisation. We work across a lot of different areas. We started off in doing deep retrofits of people's houses. That was back in mid 2000s. And the stuff I'm talking about today, the energy system stuff, flexibility stuff, we got involved in that a bit later through European projects. But we're quite a big organisation now. We have 18 staff working across these different areas, and 200 householder members, because we're a membership-based organisation. But we also supply services to a much wider range of customers apart from that. The stuff I'm talking about today is funded by two main funders under two main funding streams. One, the earlier project, which covers what I'm talking about, was funded by the Department for Business, Energy and Industrial Strategy, and that was under what was called the Domestic Demand Side Response Competition. And that project was called Open DSR, and it was to develop a demand side response system. And it's good that people have already sort of discussed what all these terms mean already, so I won't have to again. A demand side response system which is based on open source technology and existing standards for demand side response. So that was really the sort of key innovative features of the system which we use as the basis to get the money. And we're now building on that with a new project which is funded under the Horizon 2020 European Union funding. Very just building more features onto the existing system. Very similar sort of objectives, but involving a much wider range of partners around Europe, and hoping to test it in lots of different pilot sites in different countries in Europe. Before I move on to talking about PowerShaper, I thought it was good to be clear about what we mean by demand side response and the different types of demand side response. And there's been a bit of a discussion about this already, but we see that there as being really two main types of demand side response. The first is what has been called implicit or price-based demand side response, and this is where consumers adjust their demand and generation in response to varying import and export electricity tariffs. The most famous example in the UK at the moment, obviously the one already mentioned, is the Octopus Agile tariff, which presents a time-varying dynamic time of use tariff which changes over the course of the day, supposedly linked to market prices. Under these tariffs, you don't know exactly how consumers will respond because you're just giving them a price, but so it's not in a sense guaranteed, but you can sort of predict it on a statistical level using models and things like this. But yeah, it's not guaranteed. And on the system side, arguably it's sort of simple because you just need to broadcast a price, but in the home, when you're controlling things, you need to decide what to do with that price, and that has to be balanced against other considerations such as user preferences. The other type of demand-side response that we recognise, and the one that PowerShaper was initially focused on, was what's often termed explicit or incentive-based demand-side response. And this is where you receive a really specific request to do something with your demand and generation or storage at a specific time in a specific way. And the purpose of this is usually to shape the demand curve, certainly in the context of domestic and small commercial customers connected to the distribution network. So you might be just trying to reduce the peak of it, or smooth it out, or shift it around in time. And the advantage of making more specific requests is obviously that you can be a bit more sure of the response that you will get. So you still have to offer some sort of incentive linked to this, but it's much more specific in terms of what you want. And it's more complicated in the sense that you need some sort of control system to manage and broadcast these requests and target them at specific people in specific places. But it's simpler in terms of maybe control in the home, because how you respond to the request, you either participate or you don't. The other complication with this way is that you need to have some methodology for verifying whether or not someone actually did respond, and so you need some form of verification and assurance for whether or not it happened. I'll talk a bit more about how we do this with the PowerShaper service. So the PowerShaper service, which is the sort of consumer-facing side of our domestic flexibility work, developed under the projects I mentioned before. Its initial goal was really to enable people to participate in the new-ish flexibility schemes being run by distribution network operators. At the moment, it's quite difficult for people to participate in these due to the way they're set up and they're presented. And we're sort of offering people a way to do this by us acting as an intermediary. So we join the scheme on people's behalf, and then we manage the requests that get sent by the DNO, and we then turn these into control signals, which we send out to the management systems in the home, which turn things on and off. So initially it was very targeted at these schemes, but next year, as part of the European funding project, we'll be adding more support for things like behind the meter optimization and responding to those price signals, like under Octopus Agile. And then further in the future, we're also looking to use this to help people participate in other flexibility schemes, such as the national schemes, which might be run by other parties. The system itself, I mean, in some sense, it's probably no surprise. It's just a sort of command and control system. There's a server on the internet somewhere, and it sends requests to turn things on and off down to the houses and the management systems in the houses. But there are a few what we think is quite innovative features of it. So we're using a standard for demand-side response, which was first deployed in North America quite successfully, particularly in California and parts of Canada, Texas. And this is a well-established standard. It incorporates a lot of learning about how to run these demand-side response schemes. So we're using that as the basis for our system. Another innovative feature is for the assurance and verification, which I said was required earlier. We're using UK smart meters to do this. So to prove that people have actually done what we've asked them to do, we use data from UK smart meters And we sort of compare one point in time with another to show that there has been a reduction or even an increase in demand. And then finally, for our home energy management system, which is the device in the home which connects to the things like EV chargers and electric heating systems, we're using open source software and hardware as the basis of this. So we're using open source bit of software called Home Assistant, which is a massive open source project for home automation, which has integrations with thousands of existing products and services. And we package this all up and offer it as part of the service to our participants. Here's a picture of our system architecture. I won't dwell on this. You'll have the slides afterwards if you want to scrutinize this further. But it shows the sort of basic logical arrangements of all the different parts. The DSR events themselves, mechanically, what happens is once we've installed all of the equipment and as part of the trial, we start sending out these demand side response events to people. And we're doing this at the moment. So we schedule the events. This in the system will trigger some sort of notification determined by user preferences, perhaps a mobile phone text message or an email. At this point, the users have an opportunity to opt out, and there's different ways they can do that. They can do that via the website, or they can do that locally via the management system. If they don't opt out, the management system will then assume that they're happy to participate, and it will turn down or potentially even turn up load at specific times. This would, either be the EV charger or the water heaters. And there is also a possibility that their users could even override what's happening at this stage. You can do this manually on the devices themselves using buttons and switches and things. And then finally, after the event is completed, usually a few days afterwards, we will have all of the smart meter data for those users who are participating in the event, and we will then use that to verify that they did indeed turn down or turn up their demand at the right time. So this is sort of what gets spat out at the other end. This is a summary report taken from the admin side of our system, so the sort of business side of it, which shows what it's showing is the response that we managed to get at a specific time for a specific customer. The graph isn't, I have to say, the best graph, and it's work in progress. But what the graph is trying to show is that in green is the energy that was used during this time, which is the time of the event, and in red is what's called the baseline, and this is what we use to actually compare with and determine whether someone actually reduced or increased their demand. So, and in this specific case, it was constructed using average historical usage from the same day, I think in the 3 weeks previous to the event. And this is a quite typical way of constructing these baselines at the moment, as used by the DNOs in their schemes. But there are many ways you could do this. So in this case, we did achieve a turn down. I know that in this case, this was a EV charger, which was involved in this event, and it was indeed a delayed charging. So the EV charger was prevented in this case from charging for the period of event, and then it came back online afterwards and started charging again. So that was successful. Things don't always go to plan though. So this more recent graph here is from a different customer at a different time, different event. And in this case, we didn't achieve a a response from them. In fact, they actually use more energy than they would have normally during this time. And you know, there's various reasons why this may or may not have been the case. So I think in this case, most likely it was simply because the pattern of usage changed. So I think this was a water heater, and it was being operated at different times. So to finish off, I'd like to, I think, repeat a maybe point that Peter's already made, which is that as system integrators who are going into homes and trying to do these things, and I mean, we're not, you know, trying to work with any specific make or model. We're trying to work with everything that we can. The biggest single problem that we have now is interoperability. And you know, initiatives like the PAS 1878, these are sort of efforts to achieve this. But on the ground today, this is an enormous problem for us as integrators. Even during this trial, what we have had to do is basically go in and install specific equipment which we know is interoperable. And in an ideal world, we would not have to do this. We wouldn't have to replace existing EV chargers. We would be able to just work with the EV chargers that were already in place. But I think until this interoperability stuff is really solved by whatever means, and I don't have a strong opinion on how exactly that's done, but until this is solved, this is a huge obstacle to doing a lot of the things that we're talking about here in this event today. And the interoperability challenges are actually quite different for different appliances as well, and that may be something that will be picked up in other talks and in questions. So yeah, thank you for listening. There's a summary there of what I've just said.
Thanks a lot, Ben. That's great. I've got one question that's come up, which may be for other people to also answer in the panel session later. But actually, maybe you answer it. You answer your perspective, about it. Does demand side response put the control of my home in the hands of the DNO, which could then control the cost? So I haven't quite phrased that right. Just get it again.
Yeah, I understand the question. Yeah,
benefit then at the cost to me, the household.
Yeah. This is a big controversial issue at the moment. Actually, I mean, could talk quite a lot about it, but I think in our specific case, you know, we're acting as an intermediary between our participants and DNOs. So in our case, the control is with us, the intermediary, not with the DNO. And in full operation in these schemes, one of our objectives is to ensure that people are properly compensated for the use of their assets for these purposes. Now, in other contexts, in other schemes, that might not be the case, and that's certainly a concern that is going around at the moment for different reasons. Yeah.
Okay, thanks, Ben. Yeah, just one point I kind of raised, or at least I discovered when I had my EV charger installed and had a local electrician come along. And given that I've also got battery storage and I've also got solar PV as well, the electrician then recommended that I actually have the so-called tails, some of the cabling upgraded to 25 millimeters. Now, I hadn't realized until a few weeks ago that in fact there are 3 organizations that own all that metering equipment, which is around your house in terms of the distribution box, the fuse box, etc. One part of it is owned by the DNO, which is the Distribution Network Organization. In the southeast, that is UK Power Networks, Another part of that is the responsibility of the utility company. In my case, it's Octopus Energy there. And then another part of it is the responsibility of me, the householder, for which I obviously then have to get an electrician in. And it's quite a complicated arrangement to know which wires are owned by which company. But the good news is I understand that Octopus Energy are not going to charge to upgrade my wires, my cables, my tails as they call it, and for that matter UK Power Networks are unlikely to charge me for it. But it's a lot of upgrading going to be required, particularly for older houses in that respect. Okay, let's move now on to Chris's presentation. It's Chris Wright, the co-founder and CTO of, if I've got this right, Chris, Moixie Technology.
Moixie, yeah.
Moixie, sorry.
Let me just see if I can do the sharing thing. Go. So can you see that?
That's great. Yeah, if I could just ask people to actually send a message to Oriane or just to everybody and just say which breakout room you would like to go in, and she can organise that for the end of the panel session when we're going to breakout sessions. Sorry, carry on, Chris. Sorry to interrupt you.
No problem. I'm just wondering, can I turn on my video?
Sorry, can you repeat that, Chris?
Hang on. There, now you can see me sitting at home, as I have done for the last Lord knows how long. Nice to be here and talk to you about this. I think you'll find that there are some very clear themes emerging from these presentations. There's a lot of the things that have been said before that I'm going to emphasize again and illustrate again. But just to say a little bit first about Moixie and why we're here. So what you see on this slide is all of the global temperatures between 1850 and 2017. And so Moixie's purpose is to build technology that can help to deal with that. So we very much believe that by increasing the IQ or adding intelligence to battery systems, by which we mean both batteries with wheels and batteries in homes, that we can build a future powered by renewables, that this is going to be a key enabler of that energy transition, which is going to be critical. And we work with some of the largest companies in the world. We work with a lot of the energy infrastructure in various places, and also large corporates, and we'll see a little bit about some of those in a minute. And we divide how we try and do that into three places. So the first of those we call GridShare Client, which is all about delivering value behind the meter to customers from our AI technologies. The second one we call GridShare Partner, which is all about providing tools for people who have fleets of systems, fleets of devices in the field that they want to be able to support, that they want to be able to visualize, that they want to be able to control. And the third of those we call GridShare Services, and that's about kind of like, okay, so now how do we make that available to the grid to enable this energy transition, and who do we work with to do that? So to start with EVs, so we're working with Honda. So Honda have recently announced publicly that they have a very ambitious plan to electrify all of the cars that they sell, by which they mean initially battery EV and hybrids, but going towards battery EVs. And Honda also sell about 5 million cars a year, but they sell 30 million fossil fuel powered things, lawnmowers, boat engines, all of those things. And they plan to electrify all of them. So they're interesting people to work with. And we're putting together a product with them. So they're really much, you're very interested in kind of saying, okay, so if the world is going electric, then we as Honda will have to take responsibility for how those cars and other things get their energy, because if we just sort of let them be plugged in, then we risk causing problems to the grid, and also we don't deliver the value that we would like to our customers. So they partnered with Moixa to bring the intelligence in the middle of a sort of energy service that will have an energy company that you'll all recognize, providing a innovative energy tariff that varies the whole time, and also a very large energy infrastructure player doing all of the installs of the chargers. And we're integrated back to the telematics on the car, which is very important for this, because if you just talk to the charger, then you don't know the state of charge of the car, which makes it very difficult to really optimize how you're delivering power to the vehicle. And then one of the things that's interesting here is that we've worked very hard to try and come up with a solution which tries to be hardware agnostic. So we've integrated ourselves with OCPP, which is a standard comms protocol to electric vehicle chargers. It's everywhere for sort of company and public charging, but it's becoming sort of fairly standard for domestic chargers as well. And certainly is widely available. So that becomes a kind of, okay, can we do this in a standard way where we don't have to do an integration to each one? And also, can we rely on the charger itself to communicate back to the platform? And so there we're working with Vattenfall, who are the sort of national Swedish energy company, who have an OCP platform that we can communicate to, at least for the moment. So that's what we're launching there. And then obviously we have an app which enables you to visualize what your charger is doing. But here I'm illustrating also a domestic battery and how you can understand how energy is flowing, the value you're getting on it from it, where that, how much of your energy is coming from the sun, how much is coming from storage, how much is coming from the grid, and the savings you're making, and those sorts of things. And then also we make an interface that allows us to understand how fleets of things are working. So and provide tools for someone who wants to manage fleets. So quickly you start to be interested in kind of like, oh, okay, well, this is all very well, but I've got lots and lots of customers now, and now someone else needs to understand what to do or what to say when a customer calls or emails or whatever. So we need to make tools for that. And I'm actually gonna, because at least there's got to be one advantage of being remote, which is that I can easily show you. So this is a live view. So this is the Itochu fleet. So this is a corporate partner of ours in Japan. So the fleet in Japan is 25,000 devices, about 1/4 gigawatt hour of storage. So quite significant, beginning to hit sort of grid level significance in terms of the scale of the storage that we're aggregating on the platform. And you can see that right now it's the middle of the night, so there's no solar, and consumption is largely coming from the grid right now, but the batteries, some of the batteries are charging from the overnight tariffs. So you can see, understand here, like our ability to flex. So currently, the storage is charging at about 7 megawatts overall across the fleet, but we could turn up the wick. So we could turn that up to 75 megawatts, or we could turn it the other way, so discharging 75 megawatts. And you can understand like how much power we could provide over time out of that fleet. And we'll visualize also kind of the what that means in terms of energy across those. So you can see over the last day about 650 megawatt hours of energy, and what came from where and how that works. And obviously also tools about kind of drilling down to individual devices, managing customers, managing tariffs. Tariffs is a big thing. I mean, there are about 1,000 different tariffs in Japan, and we have to be able to handle all of those and have a way of enabling our partners to push those in into the system and integrate with, you know, tariff engines and those sorts of things. So all of those things are things we do: set alerts against things, manage user types, all of that sort of stuff, which needs to be made as tools for our partners. We don't want to be, unless we can't help it, taking the calls directly from customers in Japan in the middle of the night. So how do we provide value both to electric vehicles and to batteries? Well, we need to know quite a lot about the homes one by one, not on average. So what we do is we look at the historic data that we have and weather forecasting data and other metadata about that relates to that specific household, and we predict forward. So you can see on this graph, the blue line is the actual consumption, and the dotted line is our predictions, and you can see them going into the future beyond where we have real-time information. And the green line is the action of the battery that we predict and that we is actual, and the yellow line is the solar. So we have to predict that forward, and then so we predict that forward every day, and then out of those predictions we make an optimized plan. So we use kind of AI, machine learning type technologies. We create thousands and thousands of different potential plans, test each of them against the simulator for how the system will generate value, and choose the lowest cost for the household. And that enables us to deliver the savings to those customers. So here we can see, you know, for particular for this fleet of about 1,000 systems, I think, over about 6 months. Like, what difference did we make compared to the battery just running in its default plan? Well, the default plan for these systems is fairly simple, but the answer is we can make about a 14% difference. We can 14% of the household's energy can be saved by us knowing, you know, should we charge in the middle of the night from cheap off-peak energy, or should we wait for the solar, which will turn up next day? Is this a household where they use energy in the morning or in the evening, and all of those sorts of things, and making those predictions. And so across that fleet for that 6 months, that's about what we delivered as savings, which is pretty good. We're pretty proud of that. And this just kind of illustrates, like, what's the difference? Why would we not just assume a kind of an average and optimize for that? Well, what you're seeing here is, if you look at the right-hand device, you can see that some customers, they have if they're outside of the feed-in tariff, they have an export tariff, so they get paid for export. And some use so little energy that actually we can shift their energy behavior with the battery such that they actually are net negative. They get paid by the energy company overall. But other customers are paying 800 yen a day. On average, it's about 200 yen a day. But so you can see the whole point here. The point here is that these customers are very, very varied. Like, yes, there is an average, but that doesn't actually tell you how you deliver value. What you need to do to deliver value is to really understand each customer one by one, using AI technology, using machine learning technology, using those technologies from the internet to work for the customer. And, you know, and then we need to be able to illustrate that. So this is an illustration from the partner interface, where for a particular customer, like, what did they save on a monthly basis? So if the customer rings up and says, why is my device doing this weird thing I don't understand, then the call center can say, oh, you know, Mrs. Miyagi, you know, this is why it's doing it, and this is the savings you're getting, and those sorts of things. So the next thing that we're interested in around in terms of R&D is like, well, what if you had a V2G? What if you had a vehicle charger that could utilize the battery in the car as if it was a static battery using V2G technology. So you can push and pull energy to and from the battery in the car. So we did an exercise where we looked at some real sites compared that do have a battery and compared what we would have been able to provide if they had had a V2G, making two sets of assumptions. One, that the vehicle is used 3 times a week for the whole day, and the other is it's used 6 times a week for the whole week. What could we deliver? And one thing that's really interesting here is, so basically, this is all in yen, so average cost of energy with no device, no battery, no EV is about 200 yen. If you add a battery to that, you can pull that down to about 140 yen. If we add a V2G that's used 3 times a week, then actually what we can do is they can drive for free, effectively. We pull down their energy cost below what they would have paid with no device at all, and they're charging their car. So it's very interesting what that looks like. So that compares to, they would have paid 324 yen if they just plugged in and charged up whenever they plugged in. So it's interesting to see, like, actually these technologies can genuinely make a difference to what people pay for energy. And the other thing to really notice here is that by learning from each device, by kind of working for each customer one by one, what we generate is a prediction for each system and what it will do next, and what it will do for the rest of the day, what it'll do 24 hours forward. And that enables us then to make that available for the grid, because if we've got a good model of how all of those devices will operate and where they'll have flexibility, then we can take those thousands of systems and we can play them into the grid, and at scale, meaning that, you know, there's less fossil fuel capacity having to be held in reserve, because you can rely on this distributed network of aggregated resources that can provide that flexibility. This slide here sort of illustrates the range of savings that we provide and how some of them are very dramatic in terms of percentage of energy saved, you know, up to 80%. But actually what's interesting here is that we can reliably provide quite predictable savings in terms of how much cost we're saving the household, which makes it much easier to communicate about why someone would do this.
Couple of more minutes, Chris.
Mm-hmm. Yeah, so I'll sprint through the rest quickly. We also predict when EVs will plug in and plug out. It's a probability matrix of how we predict and when they'll plug in and plug out. And then just to illustrate, kind of, you know, here's a VPP contract, so a local grid constraint contract for a DNO where we were in the South Coast. We've got lots of batteries that are being dispatched by DNO when they're needed, held in reserve when they're not, and managing that contract and delivering that value to the customers at the same time as delivering the flexibility action. And you can see a group of batteries dispatching to give that load, a different group in Ireland for a frequency response. And here, this one I've included because it's interesting, because it's a group of EV chargers and battery systems in different homes, all being dispatched for the same event to give an overall response. And just a last little sprint, we're also interested in how we add value through data. So it doesn't all have to be about the energy. We can add more value. So one of the things that the systems in Japan can do is provide some backup power for homes. And that's something that the Japanese worry about a lot because they get typhoons. So this is Typhoon Haishen earlier in the year. And we can see that we are connected to the Japan Weather Service. So we monitor all the weather alerts, and they have a particular level. So if there's a typhoon predicted for a particular area with a certain danger level, then what we do is we monitor that. And then for any households in that area, we turn their systems to backup. So you can see here, as the typhoon comes along, that all of the systems at the bottom of Japan turn themselves into backup mode so that they will be prepared if there is an event. And what you can see here is, you know, here on the left-hand side, the system operating normally, and then suddenly, oh, there's going to be a typhoon, right? We'll charge up to full so that we're fully prepared in case there is one. And what you can see over on the right-hand side is it's in backup mode, it's at full, and then there is a power cut, and the system provides the power for the home doesn't notice, and you know, it's resolved, but it was in the right place to do that. And working with some of these sorts of partners. I think that's probably about it, except to say, we thought about this in 2008, and we've been at this some time. Filed a bunch of patents in 2008 about in-home optimization, about optimizing for different things and predicting for them, and that's we've branched a bunch of patents off that, but that's widely cited, and it's going to say this is something that we've been working on for quite some time.
Thanks a lot, Chris. That's great.